Okay, very good. All right, it's about five after the hour, so let's go ahead and get started. Tonight we've got some easy material so we can burn through it, and I think what I'm going to do tonight is both finish up just the little bit of chapter 8 that we didn't do before, and then go right into chapter 9. Both these chapters are really pretty straightforward chapters. There's no mystery to them, and so okay, so guys, okay. Jerry has just posted something in the chat.
Let me finish the second part of it.
Okay.
I posted it too soon.
Okay. Well, all right. Hugh, am I sharing?
Yes, you
Yes.
are.
Okay.
I'm
Okay.
looking for that, Bob.
All right. We're going to talk a little bit tonight about interference. This is just kind of to finish up what we were talking about in chapter 8. And, your book mentions, two types of interference: natural, or QRN, and then um, uh, person-made, human-made, or industrial society-made, QRM. That's an interference caused by other radio signals or other industrial activity. Now, here's a word to the wise for your test. The term QRM could appear. It is one of the possible questions. QRN is not. So QRM, that's interference caused by other transmitted signals or such things. The other one that could show up, the other Q signal that could show up on your exam is QSY. And QSY means, change to another station or change to another frequency. Okay, so QRN, this is nice to know that, QRN, essentially that's static or noise produced by, weather, storm systems, whatever. It's nice to know, but it's not one of the test questions. QRM could be, so could QSY. QSY, meaning change to another frequency. Okay. Um, oh, oh yeah, QRM. Yeah. Now, this QRM, this is not necessarily interference caused intentionally. This can just be created inside your system, inside your station, and it could be the result of improper grounding or something amiss in your radio or whatever. Harmful interference, and again, they distinguish between harmful and non-harmful. You kind of think that, well, interference you get from thunderstorms, well, it can be a nuisance, but it's not really considered harmful. It's just nature. But harmful interference is that which disrupts either your transmissions or your reception. And again, they point out it's not necessarily intentional, but you should deal with it. Willful intended interference. First off, that's never okay. It's not okay. Even if you don't like the other person that's talking, it's not okay to intentionally interfere or cause intentional interference or attempt jamming other people's signals. Yes, and in fact, Jerry talked about this. I think 2 weeks ago, talked about some person that was doing it hostilely, as a hostile act, interfering with people's signals over on the west side of the state of Michigan. He was eventually pursued, but then avoided punishment by dying. Okay.
He went to a higher court.
Okay. And I think you got life.
Okay, Bob, can I mention this?
Yes.
All right, sometimes, not as much with the FM radios, but if you get an HF radio, especially on the higher frequency, like 10 meters, you will find carriers, just a tone just sitting there. It could be something coming out of your computer. And I remember I had one computer that wasn't too well shielded, and every time I moved the mouse, I could hear some changes in that carrier. So these are called birdies, and even good radios will pick those up.
Okay. Okay. Preventing interference. Okay. As you know, as always, and I think Jerry covered this also in talking about communicating to other hams in general, and that is the use of common sense and courtesy, and not interfering with other people's transmissions or other people's QSOs, other people's conversations, and when they're in process. That's going to happen, by the way. You are going to interfere with someone else's eventually, and that can happen because where I really see this is sometimes on contest days. When I'm trying to make contacts myself, there are some stations out there that are just superpower stations. They must have excellent antenna systems and putting out a lot of wattage. And I can hear some of these people like they're sitting next to me, and I can hear them talking to other people, but I can't necessarily hear the other party. Now, that could be going on, and in fact, that could be going on. A frequency could be in use by two other parties, and maybe you don't necessarily hear one or the other. Maybe you don't hear either of them, but they might be able to hear you. So if someone does pop up and tell you, hey, you're in our QSO, we're talking, you need to move to another frequency, right? Remember, no one owns any frequency, so just common sense, patience, courtesy. And there are special when they say recognize special operations and special circumstances, that would be like on contest days. On contest days, there can still be people out there on certain frequencies just having a plain old chat.
Test and Emergency Operations Center in Western Pennsylvania.
What's that?
I'm sorry, I was trying to prep up something, but please continue. Sorry about that.
Okay. I suppose we can go over this a little bit. We talked about control point last time, and I think we covered it pretty well. But it doesn't hurt to go over it again, because this is an important point. The control point is where the transmission is operated. It's not necessarily where the transmitter physically is located. You remember last week, I told you about some guy who had his great big station up in North Carolina, great big antenna, really nice transmitter with linear amplifier and everything. But every winter he goes down to Florida, and using the internet, he controls his radio in North Carolina from Florida. Okay? And in that case, the control point is not where his radio is. The control point is not in North Carolina. The control point for that radio is down in Florida, where he's actually, doing the commands that make the radio work. That is remote control. Yes, it is. Local control is when you're just sitting at your transmitter, spinning the dials and punching the buttons. What did I miss there? Oh, automatic control. Automatic control. That's what happens with repeaters, where there's no one there, but it's being controlled through circuitry, really through software, and and there's no one necessarily physically right there at any particular point. A control operator is always required, but the control operator is not there at the switch. And the control operator is responsible for stuff that goes on when they know about it. Okay. Prohibited transmissions. Oh, yes. And we talked about this. And you know what? This probably is easiest to talk about from the bottom up. I mean, this is just common sense. A fake emergency or distress call, of course, that's absolutely prohibited. Fake calls for help, absolutely prohibited. Unidentified transmissions. Now, up at the top, unidentified transmissions. Remember, we told you that you must identify yourself by call sign in English. You must identify yourself at least once every 10 minutes and at the end of your conversation, at the end of your call. You must use your call sign, not someone else's, and you can't pretend to be someone else. Of course, obscene or indecent speech is also prohibited and can get you in trouble. Obscene and indecent also includes such things as derogatory comments about race, ethnicity, religion, gender, that kind of thing. All right, be a good person. Don't do that. You shouldn't do that off the radio either. Okay. And music. Yeah, you know what? You're not supposed to play music over amateur radio. It will sometimes happen if you have music going in the background. So, but you know, as long as it's not your intention to, play your favorite Britney Spears song over the radio, that you're okay.
Bob, there was one case, I think the FCC made an exception. It was customary for Houston to wake up the astronauts on the space station with music.
Oh, okay.
So
Okay.
I think that was, Hugh, do you remember anything like that?
I do. Sure do.
Yeah.
What did they play?
Good morning, starshine.
I don't know. I have these old dead 200-year-old dead composers that I like, so I'm not into current music.
Where's the astronaut, Bob?
Okay, no Buster Rhymes for you, huh? Okay, all right. Amateur radio, right, is not commercial. No doing business. You can, however, you can talk about amateur radio equipment for sale. I mean, as long as that's not your major business, as long as you're not a store. Ham radio online can't do it, but like Jerry could do it, or Hugh could do it, or I could do it. You know, if we were going to sell one of our pieces of equipment, we could talk about that online, and not using it on behalf of your employer. Now, the big exception to that is that teachers using ham radio in their classes, of course, they're getting paid for their work, and they're doing it for, their employer, but that's an exception, and that's totally okay. That's totally, completely okay. Okay, and no encrypted transmissions. Now, they don't talk about it here. All right, encryption, they say it's allowed for radio control signals, so if you're controlling a model craft or something like a drone or a model car or a model plane, you can use, well, you do use encrypted signals, that's the way it is, or for a space station, meaning anything more than 50 kilometers above the Earth's surface. And that would be, if you're involved with amateur satellites, you could use encryption for that. Now, one point they make here, I don't have a slide for it, but one point they make is that there is a difference between encryption and encoding. Okay, encryption, the purpose of encryption is to send information that other people cannot decode, cannot understand, that they can't, it obscures the message, right? It prevents other people from seeing what that message is. Encoding is allowed, and what encoding is that's, well, for instance, for digital communications, that's exactly what you're doing. You're taking speech or computer code. It's being encoded into digital format. It's being transmitted out over the airwaves, and it's being received somewhere else. However, anyone can receive that encoded message, and with publicly available software or other information, that anyone can decode that message. That's permitted. Okay, I think the book used examples such as well, digital communications, but also compressed files. Sometimes you send compressed files for slow scan TV or something of that nature. Broadcasting.
Would CW be considered encoding?
No,
No,
No? Okay.
no,
I just thought because you got to decode it to figure it out, and anybody can do it.
that's it. It's freely available.
Yeah.
Right. That's why I thought it might be an encoding, not encryption, but encoding. Okay.
Well, I mean, for those uneducated, like I'm teaching a bunch of boys Morse code and
Right.
telling them that it's a secret language that only they can use.
Right.
Okay. Broadcasting. Now this is fun. This is fun. Broadcasting. Broadcasting is prohibited. And by broadcasting, what they mean is sending out one-way transmissions to the general public for news or entertainment or other such things. They do make exceptions, and one is ARRL, and I think some other national organizations send out Morse code practice. They just send out lines of Morse code for people to improve their Morse code skills. Now, and there are some other bulletins and whatnot, but generally speaking, broadcasting is prohibited. It does, however, happen on ham radio, and that's something you'll hear about. That's something referred to as pirate radio, and that's where people take it upon themselves to produce little radio shows or other kinds of entertainment, and simply put it out over the air. What would that sound like, you asked? Funny you should ask. I just happen to have an example, and let me go to that.
Does that happen very often?
Yes, it does.
Oh, okay.
Yeah.
Not always on the ham bands.
Oh, wait a minute. Hang on. I'm in the wrong place. Let me get there. Now, it does happen sometimes in the ham bands, but Rich, more often it happens in the shortwave bands, not necessarily in the ham bands. And for instance, when I say shortwave bands, there's this nice organization, the North American Shortwave Association. It's really, there's a lot of hams in it, but it's really for people who like to listen to shortwave broadcasts, international shortwave broadcasts. Anyhow, they have a winter festival every winter, and it seems that someone comes on the air for them, or perhaps it's even them, and they have this program or this pirate station they call the Voice of Pancho Villa. And well, here, let's see if you can hear this.
report talks like Eagles. This is the voice of Pancho my Agra overdose in the bunker in the Y2K bunker. My hooks around the bunker. This must be the end of the world. I guess it must be the end of the world. Let me turn on my radio and WWCR and see what's on. This is WWCR, Worldwide Crackpot Radio. It's time now for the Good Old Boy Militia Hour. This is Colonel Billy Bob Johnson of the Good Old Boy Militia. Well, you know, last week.
anyhow, that's pirate radio. And it seems to pop up every time that North American Shortwave Association has their winter conference. Now, of course, no one knows when it really happens, but their conference is coming up, not this weekend, but next weekend, and if one were to want to hear that, I mean, if one were to know such things, one might tune into upper sideband 400 or 4060 kilohertz or 4.060 megahertz at midnight, and one might just hear the voice of Pancho Villa. I mean, if one were to know such things, but it's not legal, of course. Okay, let's get back to no public broadcasting. Retransmission is, but yeah, that's fine. Okay, emergency and critical situations, special circumstances. Normal rules. Okay, on emergency. All right, this is something I want to here. Let me get out of this thing. I think there is a trick question. Where am I? All right, I'm not sharing, right? Okay.
The trickiest question is almost always all of the above.
Oh no, don't do that. Don't say that. I do want to share something though. When we're talking about prohibited broadcasts and prohibited transmissions, and we're talking about, you've got this set of frequencies and you got to stay within your frequencies. But then, back in chapter 6, Jerry was telling you that, when he was talking about Aries and races and all that, and other kinds of emergency communications, that for threats to life and property, you can use any frequency, any mode that you have available. And your license doesn't matter if you're a technician and you need to use an extra class frequency in emergencies where there's threats to life and property, you may do so. Now, I want you to look at this one particular question down here, this T2C01, and that is, when do the FCC rules not apply to the operation of an amateur station? Okay, now, I just told you that in emergencies with threats of life or property, you can use the radio any way you need to use to get aid or to get assistance, right? Now, so when do FCC rules not apply? Never. FCC rules always apply. See, the thing is, this deal about using any frequency, any mode in times of emergency, that's part of the rules. So if this question comes up to you, when do FCC rules not apply? They always apply. It's just that there is in the rules this provision that says in times of emergency, you can do whatever you need to do. All right. And there's another question that can pull up. It's about the same thing. Are amateur station control operators ever permitted to operate outside the frequency privileges of their license class? And that is yes, but only if necessary for situations, involving immediate safety of human life and protection of property. Okay. It just that.
Right,
that
there is
one-
an Armed Forces Day exception that so I think it's sometime in May, where amateur radio operators, they must stay in the amateur band, but they can make contact with military radio stations that are outside the band. When you said 4080, sometimes they will go to 4.030 or something like that, and hams can talk to the guys. They listen to the military frequency and they transmit in the ham frequency. So that can happen. Armed Forces Day, I think they call it.
Okay. Okay. Well, that kind of knocks off chapter 8. I think we've done that its justice. So let's chapter 8. Let's get rid of that. And let's go to chapter 9. Okay, chapter 9. All right. Slideshow from the beginning. All right, now sometimes, Jerry, I'm sharing, right?
Yes.
Okay. Sometimes I can be a little flip about chapter 9, about safety. And I shouldn't be, because I sometimes refer to it as the don't fall off the tower or don't fall off the roof chapter. A lot of this is pretty straightforward and really common sense. However, there is stuff you should know and stuff that we should, go over a little bit. You saw this nice chart in your text. And remember the thing about electricity, right? Electricity causes burns. At the wrong or at too high of current, it can cause not just shocks, but it can cause loss of muscle control. It can cause spasms. It can cause you to jerk or to muscles to tighten up so you can't release them. If it's going through your heart, it can cause arrhythmia. It's something to be careful of. Now, this chart gives you a kind of an idea of what kind of amperage you have to get to, and it's not very high. 150 milliamps can cause a lot of pain. Even something as small as 25, 30 milliamps can give you quite a little shock, and can be very unpleasant and dangerous. So let's put this kind of in perspective. Static electricity, when you go scooting across the rug on a nice dry winter day and touch a doorknob and you get a little shock of static electricity, that actually is normally below 1 milliamp. It's normally below 1 milliampere, but it could be anywhere from 750 to up to 20,000 volts. A lot of voltage, And that 1 milliamp, you get it all instantaneously. If you got it over the period of a couple of seconds, you wouldn't even notice it. But getting it instantaneously, you get a little poke, and that's unpleasant. Lightning, on the other hand, lightning could be millions, and up to 1 billion volts, and well over 10,000 amps, not 10,000 milliamps, 10,000 amps. Now, this 10,000 milliamps you see here, remember what that is. 10,000 milliamps is 10 amperes. All right, so think about the normal amateur radio, and I was looking at the specs on my radio today, and again, I don't run a linear amplifier or anything, but my radio in the HF bands, below 30 megahertz, where it can run 100 watts, it operates at about just over 20 amperes. All right, so that's that's twice this 10,000 milliamps. Even in the VHF bands, the 6 meter band and the 2 meter band, where it's only putting out 50 watts. It's only putting out 50 watts, but it still runs about 15 amps or 15,000 milliamps. So, there is voltage, or there is current in there, and you need to be careful with it. The first thing, and all this stuff, I think is pretty well common sense. Avoiding contact is the best thing. I think what they should have started out with, though, is if you don't know what you're doing, don't open up your radio. Really, I mean, if you're an electronic technician, fine. But if you're not, this is not a place to start playing around. I wouldn't think about trying to repair my own radio. I don't have that level of technical knowledge or that level of, technical sophistication. I wouldn't even think about it. So a lot of these things, for many of us, a lot of these things, you don't even have to worry about, because you're not going to be doing these kinds of things. But if you are, avoid contact, unplug the equipment before you work on it, keep one hand in your pocket. And do you know what that's all about? You keep one hand in your pocket because you don't want both hands out there. If you get a shock and it goes from one arm to the other, it's going through your chest, it's going past your heart, and that's a bad thing. All right. Again, make sure the equipment's grounded. Use power from ground fault circuit interrupter protected circuits. Yes. Why not? Remove jewelry, of course. That can show up in a question.
I was in a course every day. People would come in wearing a metal watch, and everyone would yell out, "What time is it?"
Okay. And remember back from chapter 3, when we're, one of those parts is parts chapters, we're telling you about capacitors. Capacitors, even if your radio is turned off, capacitors can store electrical energy. It stores charge in an electrical field, and it can keep that charge even when the radio is turned off for days or weeks, depending on the size of the capacitor. Oh, storage batteries. Oh, yeah, storage batteries are are dangerous when shorted. Oh, yes, they are.
Yes, they can melt wrenches.
Yeah. Okay. So don't bypass safety equipment. Don't bypass fuses. Don't bypass on-off switches. Somebody should know when you're working on stuff, if you're going to be working on stuff. And someone should know where the master switch is. Someone should know how to turn off all the power going into the area you're working on. And someone should know to call for help if you mess up.
Okay, I'd like to make a little comment. Not all of
Okay.
it's going to be on the exam, but usually you don't have to worry about too much shock hazard if the voltage is below around 26 volts or 24 volts or thereabouts. But there are exceptions, so it's worthwhile to be cautious no matter what the voltage is. You're lucky because most of the current equipment runs on 12 volts or 13.8 volts, which is not going to give you a big shock hazard. Although if you start buying some big gear like an amplifier for your transceiver, they usually run at a little more than 50 volts and with a lot of current. So that could give you a lot of trouble. It's not like the old days where I had a power supply that made 1500 volts at just about half an ampere. I know one poke from that and I would have been laid out.
Yeah, half an ampere. Half an amp, that's a 500 milliwatts. 500 milliwatts.
No, about 7,500, no, 750 watts, something like that. But that would be enough to kill you.
Yeah, 750, okay.
Especially 500 milliamps.
Yeah. Okay. Yeah, make sure your station wiring meets code. Use the 3-wire power cords, circuit breakers, circuit breaker outlets, ground fault interrupter circuits, fuses, and don't don't use the penny fuse trick. No. Use proper fuses, proper fuse sizes. And if you keep blowing, then maybe you're on the wrong circuit. Okay. Yes, don't overload single circuits or outlets. Grounding and bonding. Okay. Now, what we're talking about here is, equalizing the voltage across all of your equipment, and that is by using, what they call a grounding bus. And this would be like a length of copper pipe or copper flashing, copper strap, where you connect all of your equipment to it. So, it avoids those RF hotspots. And then, of course, keep people away from the antennas and the radials. Lightning protection.
Yeah, can I throw in something here, Bob?
Okay.
All right, RF burns from the equipment are pretty painful and they take a long time to heal. And it's not going to give you an electric shock like the DC or 60 cycle AC, but it is going to be pretty painful. And if the power is high enough, you're going to get some very severe burns. So please stay away and make sure that kids or anyone walking by can't put a hand on your vertical antenna and get some RF burns from that.
Yeah. And a couple of weeks ago, Jerry actually showed you pictures of his of the base of his antenna tower, and pointed out that he had grounding rods attached to each of the tower legs, and this is for lightning protection. This is to try and keep lightning from destroying not just your equipment but your house. The antenna can be served not only as an antenna but also as a lightning rod. So you need to protect against that. Okay, so not only do you have a grounding rod for each leg of the tower, but those grounding rods have to be connected together. Okay. Yes, grounding rods should be, for grounding, you should try and get to ground as quickly as possible. So as straight a line as you can, no bends if you can help it, certainly no right angle bends, and as short a wire as you can get. uh, and of course, unplug or disconnect equipment if you expect lightning, if you have a thunderstorm coming. It was just 3 years ago, our immediate past president of the Hazel Park Amateur Radio Club, been a ham for, I don't know, 20 years or 25 years, maybe longer than that. He himself is an engineer, but sitting there in Bloomfield Township, yeah, he got a hit and it wiped out one of his radios. And it happens. There is insurance for that, by the way. There is insurance you can buy for that, but
I was going to mention that homeowners is not going to take care of your towers, and they might give you a little problem with your ham radio equipment, but it's fairly inexpensive. I think it's $1.40 per $100 evaluation. I used to be in insurance, and it's a very low rate, and it's worthwhile.
Okay.
Bob, quick question.
Sure.
Are some antennas more susceptible to lightning than others, or are they all kind of the same?
I would expect vertical antennas are a little more susceptible, but it depends, because you're going to think about the antenna. The antenna itself is just the radiating part. If you have a nice beam antenna, but if you put it on a high tower, you put it on a 30-foot tower, yeah, the higher you get, the more risk you have. Of course, the better the antenna works, and the more fun you'll have playing amateur radio. But yeah, you get it high enough, and it just becomes a better target.
I don't know. It's not really a rule. It depends on I guess the storm activity that's coming across, causing the buildup of an electric charge. One of my friends, he's probably around 7 or 8 blocks away from here, and he has a horizontal antenna, a dipole antenna, probably about 20, 25 feet up, and he got struck by lightning. The lightning struck his antenna, went down the feed line. He was using ladder line, and because the feed line sort of dipped near the ground before it got into his house, the lightning dissipated itself into the ground mostly instead of into the house. But it did take out one of his transceivers.
Okay. Electromagnetic radiation. Okay, now I think we talked about this even in the first chapter, is that, radiation, we're talking about just sending out electromagnetic waves. Radio frequency radiation is not the same as radioactive radiation that you get from a nuclear blast. Radio frequency electromagnetic waves, they are non-ionizing radiation. So, there's never any danger to your genetics. The only danger that you get from RF energy is, of course, burns. It heats the body, it heats the skin, and it can burn. You get up in the high ranges, the very high frequencies, and those are the frequencies you use in a microwave oven. Okay, now the 2-meter band is not there. Don't worry about it, but one must take those precautions. All right, now let me see where am I. Power density is an important concept. Power density is a measure of how much radiation you're getting per unit of well, in the case of a person, per unit of skin, how much radiation you're getting. higher power density means more exposure, and that's just it. And different parts of your body actually absorb radio frequencies at different rates, due to the size of body parts. There are safe levels. You had this nice chart in your book, and I want you to pay attention to this. On this chart, I've actually inserted 2 lines here, because what this chart is showing you is that, at very low frequency, there's much less risk at very low frequency, but as frequency begins to rise, okay, the x-axis here is frequency. So, if you're down at 3 megahertz, which 3 megahertz is like the 80 meter band, and it's nearly low frequency, but it's not. It's the bottom of the shortwave frequency band, or the HF band, the high frequency band. But when you get up to VHF, which your technician license gives you privileges in really everything over 30 megahertz. And here is where the maximum exposure is the lowest. The maximum exposure is lowest, meaning you can't expose yourself very much at these frequencies. Now, this red line here, that's the 6 meter band. So that's at 50 megahertz. The green line is the 2 meter band. So it's about 144 megahertz. You'll notice that on this whole chart, those are in the lowest permissible levels. Remember that, because there's a question on the test about that. Okay. Now we're going to talk about, and I kind of think this slide is a little out of sequence, because here they already bring up the concept of controlled and uncontrolled. What the controlled environment is that's the part where everyone knows what's going on. All right. People who are in the controlled environment know that there's transmitting going on. They know what the power, they know to take caution. The uncontrolled environment, and not only should they know, but you should, as the radio operator, should be controlling them and telling them how close they can be to your antenna, or when they need to move away, or whether you need to raise your antenna to get them out of the way. The uncontrolled environment, now this would be like your neighbors walking around your antennas when you can't control them, and they may not know that there's any kind of danger. I mean, if you're in your house transmitting, they might not even know you've got your radio on, and they might not know there's any transmitting. That's uncontrolled, and the maximum permissible exposure in that area is at its lowest. Every operator is responsible to take into consideration the safety of others. Okay, duty cycle. Duty cycle is the percentage of time when you're transmitting and you're actually sending out maximum electromagnetic waves, maximum emissions. Okay, now duty cycle, for instance, on VHF, I think we have a slide on this. Yes, we do. All right. See, different. No. Okay. Different modes have different power characteristics. If you're on FM digital voice, anytime you've got that, the button down and you're transmitting, you're sending out frequency. You're sending out radio waves 100% of the time. If you're on single sideband, you may be sending out only 20% of what. Think about think about a radio with 50 watts on FM voice. You're 50 watts. Well, you've got the button down and you're transmitting. That 50 watts is going out all the time. If you're on single sideband, though, especially single sideband without digital signal processing, you may be only sending out 20% of that energy for the given period of time when you've got the button down, when you're transmitting.
You're modulating, it's amplitude modulation. So you're actually manipulating the power output as you talk. So on average, it would probably be 20% out of what you possibly could do.
Yeah. Yeah. Whereas you remember in frequency modulation, the amplitude is always the same. It's always the same. So, you've got 50 watts, you're always putting out that 50 watts, but under single sideband which is AM, your amplitude increases and decreases depending on, how much you're talking and how loud you're talking, that kind of thing. Okay. Now, all fixed stations must perform an exposure evaluation. Now, you'll see, or I think it said in the book that for VHF, if you're at 50 watts or less, you actually don't have to do this. But, once you go above that 50 watts in VHF, or when you go into HF, where you're going to be using, 100 watts or more, then yeah, you have to perform this evaluation. Now, there's 3 ways to perform a radio frequency exposure evaluation. The easiest way is to use an online calculator. Now, I put a little link down here, and in fact, I'm going to take you to this. Here is an online calculator for radio frequency exposure evaluation. Okay, Hugh, am I sharing?
Yes, you are.
Sharing.
Oh, okay. Yes. Now this is hitlink.com, and you simply go out to this site. There are several of these out on the internet. It's just, I kind of like this one. So you just go to this RF exposure, and then it brings you up this nice little worksheet. Now, let's say that the average power that you have is 50 watts. Now, if you're on VHF, a normal base station radio for VHF will come with a maximum of 50 watts for VHF. Mine does, and the radio I had before this also did. Now, let's say you're using a dipole antenna because they want to know your antenna gain, and that's a part of the calculation. So let's say you have a dipole and that's 2.2. 2.2 decibel gain. And let's say that you have your antenna 30 meters in the air. I'm sorry, 30 feet in the air, say 10 meters. All right. And you're operating on the 2-meter band. So let's say it's 144 megahertz. Okay, calculate. Now, you get this nice little table that tells you, okay, you're at 50 watts, you've got 2.2 decibels of antenna gain, you've got 10 meters, or you're about 30 feet in the air, you're operating on the 144 megahertz, or the 2-meter band. Your estimated power density, okay, is 0.017 milliwatts per cubic, or per 0.017 milliwatts per cubic centimeter. Okay. Now, In the controlled environment, it has, this is the better part of the table. It has this nice little table here. In the controlled environment, are you in compliance? Yes. In the uncontrolled environment, are you in compliance? Yes. See, it gives you the maximum permissible exposure for this power, for this frequency. It tells you what the maximum permissible exposure is, and you see up here, your exposure is way below the limit, or the max, I should say. It's way below the max. So in this case, you're fine. Now, let's say, for instance, instead, let's say you've got an HT. Okay, so you've only got 5 watts. Your antenna gain, well, a rubber ducky probably has no antenna gain. Jerry, do you?
Well, it depends on, I suppose they're using the isotropic antenna,
Okay.
which is less than 1. So rubber ducky is probably going to have possibly a, was it a 2.1 dB gain, something like that?
Okay. All right, so let's call that a 2.1. Okay. Now, the area of interest in meters. If you're holding that thing at your head, let's say you're about 1/4 of a meter, and you're at 144 megahertz. Now, okay, for this, it says you are not in compliance. Dun, 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 dun. This is why Jerry told you, you may want to get one of those microphones so you can keep your little HT hooked on your belt and only have the microphone up by your head.
Of course, that limits the range that your HT is going to transmit. Higher the HT, the farther it'll go. So you make the choice. Your health or your reception.
Yeah. Anyhow, so this is an RF calculator, okay? I just wanted to show you what one looked like. Oh, wait a minute. I'm not sharing, am I? Hang on. Let's go back and we'll finish off this chapter pretty quick now. Slideshow from current slide. Okay. There is computer software for you to do it, to model exposure. That's more difficult. And if you want to buy the equipment, to buy something that'll measure power density, that's a very difficult thing. It's going to run you some money. Online calculator is the way to go. Okay. At low power level, no evaluation is required. Varies with frequency. Below 50 watts at VHF, you're fine. You do have to reevaluate every time you add new equipment, or if you move your antenna, or if or if you move your station. You should reevaluate. Reducing RF exposure. Raise the antenna or reduce the gain or reduce your power or change to a different duty cycle. Now, what that means is, instead of working FM, you could work single sideband. And yes, you can work single sideband on VHF. It's available. Or just simply raise the antenna. Now, this other thing, relocate the antenna. Yeah, I understand you can move your antenna, move it somewhere so it's away from people and away from The reorient I don't really kind of get. I mean, you're pointing your antenna in one direction to transmit in that direction, and if it's hitting your neighbor's house, or you know, or if your neighbor's house is too close that they're within too close in the exposure area, reorienting your antenna to another direction is it doesn't seem to, well, you're not going to be pointing in the same direction you want to transmit to. So I kind of don't understand that advice. The raise the antenna I get, reduce the power I get.
Yeah, it's sort of like that Havana syndrome where they say that some enemy people are beaming microwave signals into their victims.
Mm.
Of course, I've been receiving broadcasts through my tooth fillings for years.
Okay. Mobile installations. Yes, secure all equipment. Now, what they're talking about here is, you don't want to just have your radio sitting next to you in the car. It should be affixed somewhere. So, if you have to stop short, your radio's not going to go flying into someone else or into your windshield or, cause other issues. But it's got to be somewhere where you can operate it safely. Yeah, you don't want it too far away where you have to be taking your attention off the road while you're driving. And no local rules. Yes, if you're driving through Troy, Michigan, this is not permitted. It's not permitted to be operating mobile unless you're hands-free.
Okay,
But you can't be holding a microphone.
Yeah. Okay, Bob, one thing as far as getting the equipment secured, possibly you could put the transceiver under your seat, and most of the control heads can be detached and just fed with a cable. And these control heads are light and can be mounted with all sorts of fasteners and stuff like that, almost like holding a GPS.
Yeah,
So,
yeah,
that's
yeah.
one way of getting around that.
Yeah, there are a number of models that you can do that with. Not all, but a number of them you can do that with. And power line safety. Oh, power line. And I joke about this chapter being, don't fall off the roof. But the other thing, and Jerry has brought this up before too, and that is every now and then we read through the magazines, and a couple of years ago, there was I think in a span of about 3 or 4 months, there were 2 little blurbs, news items in CQ Amateur Radio Magazine of amateurs, hams, who were killed because their antennas, they were working on their antennas, and their antenna fell into power lines, and they were electrocuted. That's a very bad thing. When you're putting up your antenna, you really have to put it up in such a way that if something happens, that it should fall down, either through equipment failure, your brackets fail and it falls over, or a windstorm or something that blows it over. You want it to be able to fall and be completely clear of power lines. Power lines carry a lot of current and can be very, very, very dangerous. Okay. Tower work. Here's where we say, don't fall off the tower. And I won't go over this very much. You saw it in your text. You saw the picture of the guy, how he's all wrapped and tied up in a bow, and helmet, safety glasses, super harness. Yeah.
There was a very nice obituary a couple of years ago about a very experienced guy in his 50s, I think, who was doing some work on a repeater tower up about 50 feet, and somehow or other, I guess he didn't clip on right, but he went the full 50 feet. Very nice obituary in the QST magazine, but I wouldn't want to be in it.
Yeah, right. Yeah. Yeah, that's one starring role you don't want. So yeah, safety, safety, safety. They're also talking about crank up towers and how, if you're working on an antenna on a crank up tower, bring the tower down, crank it down. Either that, or if you're going to climb it when it's cranked up, you've got to block it so that, it will not come down when you're up there on it. And then it's talking about using a gin pole, which is just another pole that helps you lift antenna pieces or mast pieces. And yeah, they will say, always use a ground crew. I think there is in fact, yes, I know there is a test question that says something to the effect, when should you not use a ground crew? And that's absolutely never. Okay.
Now,
That's
one thing I avoided all this when I put my tower up by hiring a professional who knew what he was doing. He had his own workers' compensation and liability insurance, and he brought along a ground crew to help him lift things up. The ground crew would either tie pieces of the antenna up to pick up, or there's a bucket for spare parts and things like that, and nuts and bolts. And it was well worth it.
yeah. Okay, I need a little bit of technical assistance here. Because my computer seems to have frozen.
We see you moving.
Oh, I'm moving, but my cursor is not moving, and I can't do anything. I want to get to.
Is your keyboard operating? Click on the caps lock and see if that little light goes on.
Yeah, it is. What is the deal here? Even my
What can we do for you?
I'm not sure, Jerry. Oh, wait, I don't know. Back in action. I don't know what the deal was. Okay. All right. Now, I tell you what. There is no better way to get ready for the exam than to actually look at the questions. Let's go through the questions. I think we have plenty of time. And if you've already gone through them, that's great. Let's go through them again. These are questions I want you to be so sure you're going to get 100% on. So let's just run through these real quick. Okay, here are all the questions that can appear on your exam for Chapter 9. What health hazard is presented by electrical current flowing through the body? Can it cause heating of the tissue? Yes. Can it disrupt the electrical function of the cells? Yes. Can it cause involuntary muscle contractions depending on the amperage? Yes, it can. All of those are correct. Okay, Jerry, in this case, you're right. all is right.
Right.
But that's not always true. Okay, which of the following safety hazard of a 12-volt storage battery? And that is shorting of terminals. We've told you that before. And Jerry used the example of dropping a wrench on the two terminals of like a car battery, and shorting it out, and that can cause fire, and it can be very unpleasant very quickly, very quickly. Okay, what kind of hazard might exist in a power supply when it's turned off and disconnected? Now remember capacitors, okay? Capacitors can store energy. And so, yes, you might receive a shock. Okay, grounding. What is connected to the green wire in a 3-wire electrical plug? Yes, the equipment ground. And what's a good way to guard against electrical shock in your station? And this is another one. Yes, use the 3-wire cords. Connect all powered equipment to a common ground, and use a circuit protected GFI. Okay, all those are correct. All right, what safety equipment should always be included in home built equipment that is powered from 120 volts alternating current power circuits? And that is a fuse or circuit breaker in series with the hot conductor. And that's for those of you with the knowledge and courage to make your own equipment. Lightning protection. All right, they have a bunch of questions about lightning protection. I wouldn't have thought they would have had this many, but they do. Which of these precautions should be taken when installing devices for lightning protection in a coaxial cable feed line? Yes, mount all the protectors on a metal plate that is in turn connected to an external ground rod. Again, this is on that same concept of bonding all this stuff together. All right, what should be done to all external ground rods or earth connections? Oh, okay, yeah, bond them together with heavy wire or conductive strap. Which of the following is true when installing grounding connectors used for lightning protection? Yeah, now we talked about this before. You want to provide a path for the current to flow as directly as it can. All right, so that means as short a path as you can make it, and as straight a path as you can make it. And if there have to be little bends, well, that's one thing, but no right angle bends, no sharp corners. That defeats the purpose of getting that dangerous current into ground. So yeah, sharp bends must be avoided. Some of these others are just nonsense. Common grounds must be avoided. What? No, that's absolutely wrong. Okay. Which of the following establishes grounding requirements for amateur radio? For amateur radio tower or antenna? Yeah, local electrical codes, right? We talked about, yeah, you got to follow your local electrical codes. Which of the following is good practice when installing ground wires for a tower for lightning protection? Ensure that all connections are short and direct, right? As short as they can be and as direct as they can be. No corners, no sharp bends. You want to get that dangerous current into ground as quickly as can. Which of the following conductors provides the lowest impedance to RF signals? All right, and the flat strap, right? A flat copper strap would be excellent. Remember, what we talked about for RF signals, radio frequency tends to travel on the outside, not on the inside of the wire, on the outside. Something also called skin effect. And so the flat strap, that provides the most surface area. It provides a lot more surface area than straight wire. Okay, what is the symptom of RF feedback in a transmitter or transceiver? RF feedback, yeah. People will tell you your signal is garbled or distorted. Okay, radio frequency interference. Which of the following could you use to cure distorted audio caused by RF current? And that is a ferrite choke. Those things often come in little pieces that come apart that you can just clamp together on on a cable. Which of the following is a way to reduce or eliminate interference from amateur transmitter to a nearby telephone? Yes, put an RF filter on the phone. On the phone. Not on your radio. Put the filter on the phone. Which of the following can cause radio frequency interference? Fundamental overload. That just means, like a big booming station very close to you that's putting out a lot of power. That's fundamental overload. Harmonics, yes. Spurious emissions, yes. Remember, spurious emissions are just those odd signals that your radio sometimes sends out, sometimes due to equipment issues.
Especially Baofeng's.
Especially power banks. Yeah. Okay.
Yeah, the common transceiver has a bad reputation of putting a signal out when you're operating on 144 megahertz. It puts out a spurious signal on 220, and the FCC is very sore about that.
Oh yeah. Okay. What would cause a broadcast AM or FM radio to receive amateur radio transmissions unintentionally? And that is the receiver is unable to reject strong signals outside the band. There's an easy fix for that. How can overload from a non-amateur radio or TV receiver by an amateur signal be eliminated or reduced? Block the amateur signal with a filter at the antenna input of the affected receiver. Okay.
Now, this is something, call it public relations. There are a couple of answers in there that say, I'm an amateur radio operator and I don't have to do anything for you. Of course, you don't want to make the neighbors sore with you.
Yeah. Okay, which of the following can reduce overload to a VHF transceiver from a nearby FM broadcast station? And that is a band reject filter. All right. A band reject filter just blocks out a certain particular band. It's not like a high pass filter that lets higher signals through and blocks the lower signals. This is a band reject filter, rejects just a given chunk of frequencies.
Yeah, it's actually a resonance circuit of a coil and capacitor that will take the unwanted signal and shunt it down to ground so it doesn't interfere with the radio.
Okay, what should be the first step to resolve cable TV interference from your ham radio transmission? The first thing is make sure that TV coax is installed correctly. It's the coax, the cable and all its connectors are installed correctly. Okay, which of the following is a common reason to use shielded wire? Shielded wire, and that's to prevent coupling of unwanted signals to or from the wire, right? And that shielded, that's what they're talking about there essentially is, coax. Okay, which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with their radio or TV reception? Here's where Jerry says, that's right, you walk right over them and thumb your nose at them. No. Make sure that your station's functioning properly first. Okay. Try your own TV and see if you're interfering with your own TV. It may well be their television that's, doesn't have the right filters on it.
Of course, telling them, okay, throw your old TV away and buy one like mine isn't going to work either.
Yeah, well, that's not going to make you popular in the neighborhood either. Okay, what should you do if something in the neighbor's home is causing harmful interference to your station? Sure, work with your neighbor to identify the offending device. Good luck on that one. But yeah, you should try. Politely inform your neighbor about the rules. Good luck on that one too. And check your station, make sure it meets all the standards of good performance. Yeah, all of those are correct. Yeah.
There have been fads that have done a lot of harm. There used to be a touch lamp. It had some sort of a sensor. You touch the metal of the lamp and it would make it brighter. and the circuitry there would cause interference to us.
Okay, part 15, what's a part 15 device? A part 15 device, that's any unlicensed device that may emit low power signals. All right. For part 15 devices, we don't have to do anything for them, but they're not supposed to interfere with us. Okay, now RF exposure. What type of radiation are VHF and UHF radio signals? That's non-ionizing radiation, right? Remember that. Gamma radiation, that's very bad. Ionizing radiation, that is also very bad. I don't actually know what alpha radiation is, but well, I don't think I would like that either. Okay, but it's non-ionizing radiation. What do exposure, or why do exposure limits vary with frequency? And that's because the human body absorbs radio frequency energy at different frequencies, due to the size of the body part. Okay. What could happen if a person accidentally touched your antenna while you were transmitting? Yeah, they might receive a painful burn.
Ow.
Ow is right. Owie. Right, and remember, when we're talking about this maximum permissible exposure and the controlled and uncontrolled environment, we're talking about distance, not from your radio. We're talking about distance from your antenna. Okay, it's exposure from RF energy coming out of your antenna, not from your radio. You can use your radio for a pillow if you want, but it's the antenna that does the radiation.
Right. The magic doesn't start until the antenna turns the pulsating electrons into an electromagnetic wave.
Okay, how does RF radiation differ from ionizing radiation? Ionizing radiation, what they call radioactivity. RF radiation does not have sufficient energy to cause genetic damage. Right. Okay, now think back to that chart that we looked at, that shows that the lowest value for maximum permissible exposure, is in the VHF, 6 meter, 2 meter area, 6 meter band, 2 meter band area. So on this one, it says which of the following frequencies has the lowest value? And that, of course, is going to be 50 megahertz. If they offered you 144 megahertz, that would also be correct, but they don't. And the 3.5 megahertz, remember, that's like the 80 meter band. That's very high permissible exposure. 440 is higher, not as highest, but then you get out to 1,000 megahertz, and that's, again, gets pretty high. Okay, what is duty cycle, or why is duty cycle one of the factors used to determine exposure levels? And because it affects the average exposure of people to radiation. All right. Because what you're worried about is how much of this they're absorbing. So, if your duty cycle is 50%, they're only getting half of what your radio could put out. All right. What is the definition of duty cycle during averaging time for RF exposure? And that, of course, is the percent of time that the transmitter is transmitting, right? When you're not transmitting, you're not putting out anything. It's when you're transmitting. Like what Jerry says, the magic starts when, you key down and your antenna turns that electrical energy into radio frequency. All right, our radio frequency energy. If the averaging time for exposure is 6 minutes, how much power density is permitted if the signal is present for 3 minutes and absent for 3 minutes? Well, essentially what this is a 50% duty cycle, right? So you can have, 2 times as much. Okay, what's the maximum power level that an amateur radio station may use at VHF frequencies before RF exposure evaluation is required? Now remember, this is just one of those flat regulations that ARL has. So it's 50 watts. At 50 watts peak power at the antenna, yeah. If it's less than that or less, you don't have to do an RF exposure evaluation. Okay, what factors affect the RF exposure of people near an antenna, a station antenna? And yes, frequency is involved. Yes, distance is involved. Yes, radiation pattern is involved. Now, remember on that software we went to, that hint link, that piece of software that we used to determine whether you were in compliance or not, it asked for the frequency, it asked for the power, it asked for the distance. Now, it didn't actually ask for radiation pattern. So if you're using a beam antenna and pointing in the opposite direction, it would matter. Okay. Which of the following is an acceptable method to determine that your station complies with RF exposure? Well, can you determine exposure by a calculation based on this FCC operating engineers technician bulletin 65? Yes, you can use that. Can you use computer modeling? Yes, you can use that. Can you do your own field strength testing using calibrated equipment? Yeah, if you want to spend the money, you can do that. Yeah, all of those are correct. Okay, the computer modeling, of course, is the easiest way, and that hintlink.com was one that I particularly like. There are others out there. You can Google for them. Okay, how can you make sure your station stays in compliance with RF safety regulations? It's simple. You have to reevaluate every time you change equipment or move equipment. Okay. Which of the following actions might amateur radio operators take to prevent exposure in excess of FCC supplied limits? Well, relocating the transmitter won't do anything. Increasing the duty cycle is the wrong way to go. So obviously all of these correct. Obviously that's wrong. No, it's relocate the antenna. Remember, for exposure, we're talking about distance from the antenna, not from the transmitter, distance from the antenna. Okay, mechanical safety. Which of the following is an important safety precaution to observe when putting up an antenna tower? And yes, like we talked about, just stay clear of overhead electrical wires. Remember, the two big safety hazards in amateur radio at this level is, falling off the tower or falling off the roof, and then having your antenna fall into power lines. Those are the two biggies. So yeah, stay clear of power lines. What's the minimum safe distance from a power line to allow for when installing an antenna? Yeah, you want it so that that if your antenna falls, you want to be at least 10 feet from any power line if it falls. All right, so you need to plan for that. And what's considered to be proper grounding method for a tower? Yes, separate 8-foot long ground rods. Yeah, and this is what Jerry showed you with his tower. 8-foot long ground rods pounded into the ground. One for each leg of the tower. If your tower has 3 legs, you need 3. If your tower has 4 legs, you need 4. Okay, you bond to the tower and bond to each other. And why should you avoid attaching an antenna to a utility pole? Well, again, this is another thing. You need to avoid high voltage power lines. You want to be away from them as far as you can. And what's the purpose of a safety wire through a turnbuckle? We didn't talk about this at all, but this is, when you're using putting up guy wires. If it's a permanent installation over time, just through normal vibration and whatnot, those wires can come loose, but putting a wire through the turnbuckle and fastening that down It prevents loosening of the wire from vibration or other, vibration happens, like when the wind blows and your tower moves just slightly, just enough, back and forth that over time, over the years, things can come loose. Okay. When should members of a tower wear a hard hat? And wear a hard hat all the time. Because you don't want your buddy working up on the tower to drop a wrench or a screwdriver or really anything else on your head. Okay. What's a good precaution to observe before climbing a tower? Carefully inspect your harness. Yeah, and safety glasses. Under what circumstances is it safe to climb a tower without a helper or observer? And I told you about this one. And yeah, the answer they want is never. They don't care whether you're doing electrical work or not. When you're climbing a tower, your first big danger is falling. Okay. So yeah. You're going up the tower, you should have an observer or a helper. And what is the purpose of a gym pole? And that's to lift tower sections. Remember, that's that additional piece of equipment you use to help raise up, antenna sections or mast sections. Which of the following is an important safety rule to remember when using a crank-up tower? And that is simply don't climb the tower when it's cranked up. Or if you must, make sure that you have some blocking device installed so that you're absolutely sure that tower will not, collapse when you're up on it. Okay? All right. Most of that's fairly straightforward. And I'll tell you what, Jerry.
Yes.
Jerry and Hugh, that is what I wanted to cover tonight. We have just gotten through, we have finished up through chapter 9. Now, which is the end of the book.
Okay, well,
what I was thinking, we are actually scheduled for next week also, but what I was thinking is, we could show up, and if people want to review any particular part, any chapter, any subject, we could be here for that.
Sure.
If you guys would like.
Or are you like the ninth graders I try to teach, and they knew everything?
I've been teaching this class, and I think this is my seventh time with you, Jerry, and I still don't know everything, so.
I think it'd be a great review for next week, because sometimes you just go back over it and then you have more questions. Like, I spent some time just looking up equipment and everything, and I had some questions like on antennas and things like that I'd like to ask, for next week.
Oh, that'd be great. That'd be super. I think that's a super use of next time, is just to open it up for questions, or if there's any particular topic you want us to hit the highlights of again, that'd be fine.
Oh, sure. That's it. And as far as the best radio, all I can ask is what's better, an F-150 or a RAM? I mean, you'll start a week-long discussion that way. We can start a months-long discussion on radios.
Okay. All right. Well, that's what I had for tonight.
Okay.
Let me stop sharing here. Okay.
If everyone would take a look at that chat and copy out the web page so you can get your own copy of that. It's got a different point of view. It was used. This is a PDF manual, license manual that was used by an associate of ours, lives in Ann Arbor, about 50 miles away from us. He's been conducting Hammond one-day courses. for quite a few years. And this is a good preparation, good review for if you, the day of the of the exam or whatever. I'll also try to send out some other resources, including what kind of equipment to look for and so on and so forth. I found something that was done by a Utah ham that has good stuff, including Utah repeater frequencies. You don't need that, but it's got a lot of other good information. Okay, Kelly? Kelly?
Yes. Hi. Can you repaste the information you just said in the chat? Because like when I logged in, I don't see all the chat messages.
There's only
Oh, I know, Jerry, I know what she's saying. Since she logged in late, so she didn't get it. Here, let me do that.
Yeah. Thanks.
okay. Can you do that?
How about that? Oh, no, wait a minute.
Wait. Is this?
No, hang on. That wasn't the, hang on.
Oh, yeah. I need the link.
Yes.
All right, got it. I got the other part of his message. How about that? Okay?
All right. I got it. Thank you.
Okay.
Okay, and I'll send the other resources as I get it. I have a little one that's a little letter I send, whatever young ham should know. But, it's hear different views, different opinions, and it'll be valuable for you. Okay, and remember, take your exam before July 1st, because then the questions will change all over the place.
And guys, really, the more times you take those practice exams, the better off you'll be. I've tried to go through some of the questions for the chapters I did, but the more you do that, just because we've been through it once doesn't mean it's not good to go through it many more times. It is. Okay, and that's, I guess, it for tonight.
Okay, that's a good review of safety and all that. You've done well, Bob.
Okay. Well, thank you all, and I hope to see you next week. If you'd like, the review, if you're solid and ready to go, then that's fine. We'll be here if you want to show up, and if not, Jared and I will tell dirty jokes or something.
Yeah.
I'll probably be there next week, guys, but I just want to say thank you for spending so much time with us, going over all this material. This has been very invaluable to me.
Oh, thank you.
Agreed. This was been a great.
You guys are worth it.
Yeah, absolutely. You guys did a phenomenal job, and I enjoyed, the class and getting your points of view. Thank you so much. Appreciate it.
Okay, and drop us a line. Let's know what your call is when you get the license.
Absolutely.
For sure.
Make sure you get active in the club, in your local club, because Kelly, did you get my email about clubs in Washington?
Your email. Let's see. The one you just sent, like. The one you sent earlier today? No, wait.
This is last week. I said something about an Alexandria radio club seems to be active enough that would give you the kind of help, and you can check with them to see if they're still doing exams.
I don't think I saw an email from you about that, but I do know about that because I was researching them.
Oh, good.
I was researching them the other day.
Okay, great. All right. Good night.
Good night.
Good night, everybody.
Good
Thanks.
night.
Bye-bye.
Bye.
See you around.
Good night, Jerry. Good night, Bob. Another Bob.
Good night, Hugh boy.
Good night, all.
All right.